Hello students, welcome to EPG Pathshala. I am Dr. Prasanna Kumar Patra from Utkal University, Bhubaneswar. Today we are going to discuss about the module Catch-up Growth, Maturation, Growth References and Standards from the paper Human Growth, Development and Nutrition. Let us see what we are going to learn from this module. We will able to understand the concept of catch-up growth, have clear understanding of related topics like canalization and compensatory growth, know about the factors affecting catch-up growth, also know about growth standards and references. Growth refers to the progressive development of a living being or path from an earlier stage to its maturity, including increase in size and development as a series of changes by which an individual embryo becomes a mature organism. Or we can say growth refers to increase in size of various organs and parts of body by multiplication of cells and intracellular components during a period of commencing from fertilization to maturity. Growth is actually a result of three processes: increase in cell number, which is called hyperplasia, increase in cell size, which is called hypertrophy, and increase in intracellular substances, which is called accretion, which underlie maturity and differentiation. Development or maturation is the increase in functional capacity for producing specialized cells from unspecialized ones and complexity in skill progression. Therefore, growth is increase in terms of quantity while development in terms of quality. Both are target seeking and dynamic in nature. The end point of growth is size attainment by adulthood at a rate less than 1 centimeter per year. The end point of maturity is the functional ability of an individual to procreate and not simply be able to produce viable sperms or ova. Growth remains the chief phase of biological activity up to about 20 years of age, whereby height, weight, body build, etc. of a person increase till he reaches his adult age, and afterwards, sooner or later, starts degenerating too, marking the beginning of older or senescence age. However, the rate at which these changes take place differ in different stages of growth. For example, during prenatal, neonatal, infancy and adulthood, growth rate increases very rapidly. It slows down during infancy and gets stable during adulthood. However, during old age, cells and tissues start degenerating. These processes are highly influenced by both genetic, which is intrinsic, and environmental, extrinsic factors, including release of endocrine and exocrine hormones, especially growth hormone, genetic aberrations, epigenetics, nutrition, season, climate, altitude, socio-economic condition, psychological condition, race, and ethnicity. In case any of these factors are not available or becomes unsuitable, it would hamper the proper growth and development of individual. Here we can see different factors affecting growth. They are, the major factors are genetics, environmental factors and endocrine factors. Environmental factors include nutrition and food, altitude, climate, urbanization, socioeconomic status, size and social mobility, whereas endocrine factors include body shape, seasonal rates of growth. catch-up growth. The term catch-up growth was introduced by A. Prader, J. M. Tanner, and G. A. von Harnack in 1963 to describe the increased growth velocity which occurs in children after a period of growth retardation when the cause of the growth retardation is removed. It is the growth velocity above the statistical limits of normality for a particular age during a defined period of time, following a transient phase of growth inhibition. After illness or starvation, which is a period characterized by slow growth, there has been found tendency in the younger subjects to bridge the deficit as soon as possible and catch up with the original growth curve. This is known as catch-up growth. A graph showing catch-up growth. The velocity during initial period of catch-up may reach 3 times the normal for age. The term compensatory growth is sometimes used by nutritionists to describe a similar phenomenon. However, that term was first applied to the quite different phenomenon of the replacement growth of organs or parts, thus showing compensatory growth. Catch-up may be complete or incomplete. If the stress has been severe, and particularly if it has been applied early in the animal's life, then even though a catch-up velocity may be established for a while, it may be insufficient to return the animal completely to its normal curve of growth. The endpoint of catch-up growth is to take an organism towards, or in favorable circumstances, right onto its original retardation growth curve. In the former case, catch-up growth is said to be incomplete and complete in the latter. Catch-up growth and compensatory growth appear to be synonymous, but they are not. Compensatory growth is not only used to describe the growth of whole organism, but also the overgrowth of a single or part of an organ when another part is removed. For example, regeneration of liver either after its partial hepectomy or due to removal of its part for purpose like organ transplantation or donation. Hence, compensatory growth could actually be the effort of an organ or its part to overcome the effect of some functional inadequacy. For achieving this, the remaining part or cells of the organ undergo the basic processes of growth, which is hyperplasia, hypertrophy, and accretion. In other words, it is the type of growth that occurs mainly after the loss of a mass of cells or tissues or part of an organ itself. Compensatory growth may be viewed as being controlled by a simple feedback mechanism, while catch-up growth is rapid growth that compensates for the loss of potential tissues and thus cannot be accounted for by a simple feedback mechanism. Mechanism controlling catch-up growth must be able to foresee lack of growth response of a tissue, while the mechanism of checking compensatory growth reacts to the permanent loss of a tissue. Canalization. Canalization is the tendency of a trait to follow a certain course or trajectory over time. Growth being a dominant biological activity from prenatal phase till the attainment of adulthood leads to many physical and biological changes in an organism. Rapid growth during infancy, which slows down throughout childhood, suddenly increases again at adolescence and puberty, which then finally ceases at adulthood. This cyclic and periodic acceleration and deceleration of growth during different phases needs some mechanism to keep a check on it. Such a controlling system is very dynamic and complex that makes the growing child return to its path of growth after deviation. This tendency to keep to a narrow and predictable track of growth is called canalization. It is a prerequisite for catch-up growth. If normal growth is not canalized, then it would not be possible to recognize the phase of catch-up growth. Canalization is the individual growth curve that parallels the centile curves of growth charts. In the pre-pivotal period, canalization is clearly recognizable, but thereafter its presence becomes less pronounced. Hence, catch-up growth spots is easily recognizable in the pre-pivotal period, and thereafter it is often impossible to discriminate between pivotal growth spot and catch-up growth acceleration. The term canalization was first used by C.H. Waddington in 1957 to describe the pattern of growth in all children that is more or less parallel to a particular centile or with some imaginary canal in an environment that does not constrain their growth. It is most likely that this pattern is genetically determined and a target-seeking phenomenon whose main aim is to take an individual to the adult stature in an unconstrained environment. Here, we discuss different factors affecting catch-up growth. It is not in all cases that catch-up growth takes place and resumes the normal growth of a person. In several cases, the severity or duration of the insult is so much that catch-up growth is never able growth to turn up, and the growth rate is never able to return to its original pace, resulting in permanent stunting of growth. Therefore, the harshness and the longevity of the constrained environment drive the movement of catch-up growth. Some of the cases have been discussed below to explain the response of catch-up growth in each of them. First, malnutrition. It is the most common cause of stunted growth and underdevelopment. Prolonged malnourishment results in permanent stunting and growth inhibition. However, severity of undernourishment results in the faster pace of regaining the growth rate, whereas undernutrition in the initial stages of life may have very harmful effects on the growth of a child, leading to slow growth initially and later leading to underdevelopment. Next is celiac disease. It is a kind of abnormality in which the gut lining inhibits the absorption of food, resulting in the child being starved. Since it causes malabsorption, growth retardation in the initial stages of growth is witnessed, leading to breakdown of normal linear growth and short stature. Another factor, growth hormone deficiency that affects catch-up growth. Insufficient production of growth hormone in the body is another one of common factors responsible for stunted growth and growth retardation, especially in the younger ages. The next is hypothyroidism. It is associated with growth failure due to decreasing effects of thyroid hormones on the skeleton growth. It also leads to a secondary reduction in the release of growth hormone. However, if treated properly at right time, the growth rate can pursue its original rate, ensuring positive catch-up growth. We discussed the last factor that affects catch-up growth. It is intrauterine growth retardation. It is diagnosed when the birth weight or birth length is lower for the gestational age of the infant. Major proportion of children with intrauterine growth retardation tends to attain catch-up growth in the first 2 years of their life. However, 20 to 30% of intrauterine growth retardation or IUGR affected children are not able to catch up at all and remain underdeveloped. The probability of catching up completely depends upon the damaging agent, its timing of occurrence and duration of damage. Maturation. Barry Bogan defines maturation or development as a progression of changes, either qualitative or quantitative, that lead from an undifferentiated or immature state to a highly organized, specialized, and mature state. The end point of maturation within the context of growth is the attainment of adulthood, which is the state of being a functionally mature individual. Functional maturation in the biological context implies to the ability to successfully procreate and raise offsprings who themselves will successfully procreate. The process of maturation continues throughout life. It begins at conception and ends at death. Thus, growth and maturation are closely related and both must reach functional and structural endpoints for providing the opportunity of successful procreation. Maturation is not linked to time in a chronological sense. In other words, 1 year of chronological time is not equivalent to 1 year of maturational time. Although each individual has passed through the same chronological time span, but that does not mean that they would have some rates of maturation. Maturation is often assessed by the identification of maturity indicators that are discrete events or stages recognizable within the continuous changes that occur during the process of maturation. There is variability of maturation within an individual, meaning that two events are not mutually related or associated. Maturation could be assessed using the following indicators: skeletal maturity, dental maturity, sexual maturity in terms of development of secondary sexual characteristics among both males and females. Growth references and standards. While dealing with huge data on human growth and development to come up with outcomes revealing the trends and patterns of growth, it becomes important to have certain reference with which the collected numbers could be related and compared. Growth references and standards are essential components in human growth and development studies. Their value resides in helping to determine the degree to which physiological needs for growth and development are met during the important childhood period. Beyond their usefulness in assessing children's nutritional status, many governmental and United Nations agencies rely on them to measure the general well-being of populations, formulate health and related policies, and plan interventions and monitor their effectiveness. Growth standards and references describe The standards for constructing following charts, that is length by height for age, weight for age, weight for length, weight for height, and BMI for age. Growth references and standards are essential components in the human growth and development studies. Their value resides in helping to determine the degree to which physiological needs for growth and development are met during the important childhood period. The growth reference aims to describe the growth pattern in a population. It aims to prescribe what the normal growth pattern should be. In order to prescribe, it is important that growth standards are based on data from people without known risk of growth faltering. For example, the WHO growth standards excluded not only infants with mortality but also infants whose mothers did not follow recommended breastfeeding and non-smoking guidelines. A growth reference is a table or chart summarizing how an anthropometric measurement such as height, weight, etc. changes during childhood based on a defined reference sample, and the charts consist of selected centiles of measurement at different ages of childhood. Purpose of growth reference is to account for age and sex differences in anthropometry. In practice, it is used in two contexts: as clinical sign to monitor the growth status of individual children, and as a public health tool to summarize and compare the anthropometry of groups of children. The construction of child growth curves requires a careful, methodical process. Rigorous methods of data collection and standardization are followed during the entire study. Sound procedures for data management and cleaning are applied. As a result, the anthropometric data available for analysis become of the highest possible quality. The selection of the best statistical approach to construct the standards follows a broad consultative process. Growth standard. On the other hand, growth standard represents healthy growth, whereas reference makes no claims about the health of its reference samples. Therefore, a standard is better than a reference for diagnosing the growth disorders, always assuming that the standard is appropriate for the child being assessed. In practice, reference is easier than a standard or to construct, as there is no need to define good growth or to exclude individuals from the reference sample who fail to achieve it. So students, let us summarize what we learned in this module. The biological phenomenon of catch-up growth is a strong inherent will and power of a child to resume and maintain its predetermined growth pattern. The multifactorial nature of catch-up growth is revealed by the fact that not only among different diseases but also among different individuals with the same disease, variability in following up, catch-up growth has been witnessed and supported through various studies conducted in different parts of the world. Apart from nature, nurture or gene environment effects on the pattern of catch-up growth among different individuals in different settings, the intensity, duration and the time and type of insult hampering the growth of individual along with the efficacy of the treatment or therapy provided and the time at which it is being provided. For example, such a treatment would have maximum positive influence on the growth pattern if provided at the initial stage of exposure to the insult, while it would have minimum effect if provided afterwards when there are no further chances of improving the growth. It represents the major influencing factors. Maturation being a progression of changes that led from an undifferentiated or immature state to a highly organized, specialized and mature state results in the functional maturity of an individual. In a biological context, it refers to the ability to successfully procreate and raise offspring who themselves will successfully procreate. It is not a strict time or chronological age dependent process. Hence, two individuals of the same age may not have the same level of physical maturation changes. Moreover, not even two maturation events are synchronized to happen in the same individual. Therefore, there are methods of assessing the level of maturation using certain physical features or indicators. They are skeletal maturity, dental maturity and sexual maturity in terms of development of secondary sexual characteristics among both males and females. Growth references and standards are essential components in the human growth and development studies. Their significance lies in the fact that they are really very useful in assessing children's nutritional status. Many governmental and United Nations agencies rely on them to measure the general well-being of populations, formulate health and related policies, and plan interventions and monitor their effectiveness. For constructing following charts, length and height for age, weight for age, weight for length, weight for height, and body mass index for age. Growth references and standards play very important role as they determine the degree to which physiological needs for growth and development are met during important childhood period. Thank you.